Is it squared?
Wait, no. It's in
Cubed.
Yeah, interesting.
It's cubed. Okay, now what? So 4/3 pi.
4/3 pi, 10 cubed.
Okay, so 10 cubed. Okay, and then what'd you get?
4,188.79.
Just like that? All right, is there any questions on this?
No.
All right, let's move on. Next page. So, what am I looking at here?
3D figures.
Okay, so this is 3D figures, right?
Yeah.
Is there a fraction with the first 3D figure in our formula? No. So, we've got pi. So we're going to go ahead and use the symbol for pi. So on every single one of them, go ahead and write in a pi. Now, how do I deal with the radius on this one? What's my formula say about the radius? Radius squared. Do I have a height with this 3D figure? So then, therefore, what is my formula? Big BH or PR squared, H. All right, what about my next one? Does my next one have a fraction?
Yes,
1/3. What do I do with the radius on this one? Do I cube it on a cone? It's the same thing as a squared. Do I have a height on a cone? So then what's my formula here? The filled in formula that I'd fill in.
V equals 1/3 pi radius squared height.
All right, what about my last one? Okay, hold on. We're not doing the formula yet. What's my fraction? 4/3. What do I do with my radius?
Cube it.
Yeah, I cube it. There's 3. Do I have a height with the sphere? No. So then what's my formula here? Sorry, waiting on a tablet. My bad. It's just slowly just going. There we go. So, 4/3 pi r cubed. All right, is there any questions on this? All righty. Then we're going to go ahead and move. Okay, so there is a new thing called surface area that you guys are learning today. There is 2 different types. There is lateral and there is total. Lateral is like, have you ever been to the supermarket and seen the cans and the label? Lateral works just like that. It just goes around the side. Total would be like if I was to paint this room, let's say pink. No, I do not like pink, but it's an example. I would paint the ceiling, I would paint the walls, and I would paint the floor. That means everything gets covered. It's like a Christmas present. You're covering the entire thing. That's the surface area, the total surface area. Today, we're actually going to be dealing with cylinders. So that means we're going to be wrapping our cylinders. We're either going to be wrapping the whole thing, or we're going to just be wrapping just like a label for a can. So cylinders have 2 bases that are circular. So your first word is circular. And 1 curved lateral surface. So you have your base that's circle. You have a base that's a circle. And then you have this lateral area. The height of any cylinder is the distance between the 2 circular bases. All right, is there any questions up till here? I'm filling in my notes a little bit too here. Now, if I was to unfold the lovely little cylinder into what we call a net, we'd have two circular bases, and then you'd also have your lateral face. So the lateral face, what shape is that? Rectangle. What's the area of a rectangle? What's the formula? Base times height. Thank you very much, Stephen. Now, what's my area of a circle? Area of a circle. It starts with pi. What do you got? Just a circle. Two-dimensional shape, not a sphere, a circle. So it's pi r squared. Yes, Gio. And since I have two of them, that's what it looks like. Now, how many of you noticed that the formulas look a little different? Which part of it looks really different? Total surface area, but look, if I add the two circles, so if I do the two circles, better yet, I'll just go ahead and highlight the two circles. Now, according to this, though, do these two match? Are they the same? It's not a trick question, I promise. Do they look the same? No. They don't look at all the same. One has a B and an H, the other one has a 2 pi RH. They both have an H. So they both have an H. I'll give you that. But is the rest of it the same? Does it even look close to the same? No. So, you're like, hold on, but why isn't it the same, right? This would be a valid question that, yes, you should be asking right now. So, your lateral surface, if you'll listen, I'll tell you. I want you to notice something real quick. If you look where I just went ahead and darkened it in green. Y'all see this right here on the edge? Those two spaces are the same. You okay with that? Okay. So the top of that lovely little rectangle makes a circle when I fold it together. Y'all good with that? So if I was to do the circumference of a circle, my formula is 2 pi r, correct? Now, this little green is also the same as where we get our base from, right? So what we're saying is that little b, our base, is the same as the outside of a circle. I'll let y'all wrap your mind around that for a minute. So the bottom part of a rectangle, or the top part, however you want to think about it, if you were to make that into a 3D shape and put both ends together, you'd create what? A circle. And the outside of a circle, could I measure that? No. Yeah, I can, right? Circumference. That's what circumference is. It's the outside of a circle. It's the outside edge of a circle. So if I was to break this little circle edge right here, I could basically create my base, correct? Which is why the formula is what it is. That's why I can take the circumference of it and call it the base. Now, total surface area. All you're doing is you're adding the two bases. Yep, we're adding the two bases to the formula, which is why you have 2 pi r squared. And as always, guys, remember that if you get stuck or you're not sure, these love little formulas are on your formula chart, which is available at the very beginning of your binder. All right, so we're going to use the table to help us. So our lateral surface area is 2 pi RH. Total surface area, 2 pi RH plus 2 pi r squared. Everybody good with that? Now, it tells us we're using 3.14 for pi. So what I do is I'd write 2 times 3.14 times, what's my radius?
6.
6 times, what's my height? 13. So remember, your bases are your two ends. The base doesn't always have to be the one that's on the ground. So then, what becomes my solution? What's 2 times 3.14 times 6 times 13? Okay, what is it? 489.84. And we're going on around to the nearest hundredth, just because I know on some of the IXL practice it's been asking me to do that, and there's been some struggles there. All right, what about my next one? What do I write there? Two times. What's pi? Yeah. 3.14. What's my radius? 6. What's my height? Am I done? No. Plus 2 times 3.14. What's my radius again?
6.
And 6 squared. Then you just put all this in your calculator.
715.92.
And that one's an easy one because you didn't even have to round. Now, with this one, guys, since we're talking about area, we'd have units squared. Does anybody have any questions on this one?
Put cube after unit, put 2 instead of squared. After unit, you put 3.
Yeah, it's supposed to be 2.
I thought it was 3.
So, it's only 3 when there's volume. So, let's look at this. What are my ones that I'm multiplying that has a unit? 6 and 13, right? Now watch this. 1, 2. 1, 2. There's only 2 units. So if you ever get confused, you can always count that. That was a really good question and a really good catch. All right, any questions up to here? Does anybody need more time to write this down? No, we're good? All right, turn your page. We're going to do one on this page, and then we're going to flip over to the other page. And I want to do number 3. Yep, I want to do number 3. So I want to do 2 pi RH. So what is my radius? And we're going to still use 3.14 for pi. So what's my radius? 2.5?
15.
What do you got, Martin?
10.5.
10.5. Martin, how'd you get that?
I divided 21, but I divided 21 by 2.
Remember, your diameter is 21, and if I do diameter divided by 2, so if I do diameter divided by 2, I get radius. So write that in there. So then what's my height? 15. So what do I get when I multiply all that out?
You get 989.1.
989 point what?
1.
Y'all good at that? Okay. Now, this would be inches. If I can get my little stuff to work here. Squared. All right. On the next one, you're going to start with your formula. So inches squared. We're going to start with the formula. I'm doing one problem, but I've also got to cover total surface area too, right? So 2 pi RH plus 2 pi r squared. So I'm already put in my one side of my formula because I already know it. What's my other side of my formula? Two times, what's pi? 3.14 because it tells us I have to use 3.14. 10.5, and don't forget to square it.
And it gives you 1,681.47.
So 1681.47.
Yeah.
And yet again, it's inches squared because it is area. All right, any questions up to here? Does anybody need more time to write this in? Okay, I'm hearing you. Okay.
Uh-oh.
So if you guys had to pick what you found was the hardest, which one would y'all do?
Anyone.
So I'm hearing a lot of 6s. So I told you just a minute ago that I thought number 5 was the easiest. It is. So y'all are saying number 6. You have chosen wisely. Because 1 through 4 is just figuring out which formula. Which means all you had to do is look at it. There was no calculation. All you had to do was figure it out. So y'all chose wisely. 6 or 7 would have definitely been the harder of the 7.
Which one was harder?
They're both. So I'm hearing, would we want to do both of them? What do y'all think?
Yes.
All right, majority rules.
I want to do this. I'm not.
Quit being lazy, Luis. Okay, so we're going to start with lateral surface area. Lateral surface area, start with your formula first. And what does it tell us? Use 3.14 for pi.
3.14.
And on this one, let's go ahead and round to the nearest tenth. Let's round to the nearest tenth. So I'm going to fill in from my formula what I know. Now, what is the radius of the cylinder that Lorenzo's working on?
Wait, the radius.
Radius. So all you have to do is go find Lorenzo.
8.
8.
8. And then the height is 5.
And the height is 5. All right, now, what do we get?
251.2.
And let's go ahead and pull up the units. So it's units squared. Now, is this the same formula he had?
No way.
No, so what was his formula he used originally? What formula?
Oh,
2
pi.
Don't read me the formula. What is it?
2 pi r.
That's reading me the formula. What is it? We found the lateral surface area. Is that what he found? What did he find?
Total surface.
He found the total surface area. That's what I'm wanting. Total surface area. And I will write these on the board for y'all too. All right, number 7. We're going to do Katrina. Cool. So 2 pi RH. Is this helping us get through talking about cousins and trying to comment on it?
Yes.
Is it helping us get done?
No.
No. So are we squirreling?
Yes. No.
Yes. Is that respecting your time?
No, come on.
Stop swirling around.
So stay with me. All right, so we're going to start with our formulas. So, what am I using for pi? 3.14. What's the radius for Katrina?
2.
2. What's your height?
5.
Remember, you could have found that up top. And I'm trying to use pi instead of 3.14. Are you writing this down, Luis? You need to write this down first.
Dang, man. Didn't even get that down.
Where am I?
You got what? Okay, I'm hearing the 2 different numbers.
You got 86?
87.
Okay, what does the rest of y'all get? I got 2 conflicting answers.
It didn't let me get it. I heard about you.
What do we got?
87.32.
That's what
Remember, I'm looking for nearest tenth.
it's
Hello?
How are you?
I'm well. Is DeMarcus Talley present?
Yes, he is.
Needs to be in the office with his things, please.
You got him.
Thank you.
It's 75.36.
You still go by.
It's 75.36.
I got 87.
Oh wait, I didn't put the carry. Okay, I'm not.
And she's got units.
2.
I didn't put the carry.
Let's go back and